Hello students, my name is Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Part Gandhinagar. I am the subject matter of Power System 2 subject, which is in the 5th semester Electrical Engineering, and GTO subject code of this subject is 3150911. Students, we are currently discussing the practicals related to the Power System 2 subject. So till today we have discussed the 5 experiments of the Power System 2. Now today we are going to discuss the 6th, 7th, 8th and 9th combined in this session. Means all these 4 practicals in this combined in this session. So the data which we are feeding for the power simulator software is same for all the 4 examples. They are having the different type of faults, and that we are going to solve using power simulator software. So the experiment number 6, which indicates that a balanced 3-phase fault analysis using power world simulator, in which we need to find out a balanced 3-phase fault at bus 3 through at fault impedance ZF is equal to 0.1. So this is the first task that we need to perform, and then after the 7th experiment we need to find out a single line to ground fault for the same data. This is the data that we are going to use, and I will show you this data in detail, but I am just showing you that which experiment we are going to perform in this session. So this is the 7th experiment in which we are going to find out the single line to ground fault at bus number 3 means at the fault impedance ZF is equal to 0.1, and in the 8th experiment, that is for a line-to-line fault analysis using power world simulator. So in which the line-to-line fault is at bus 3, that is having a ZF is equal to 0.1. So we are performing all this fault, and we are going to check the value, means the voltage and the current, or all the power levels, or the we can say performance of the power transmission network that we are going to use over here. Means all the parameters that we are going to check for this experiment. And the 9th experiment, that is double line to ground fault analysis using power world simulator. So this is the data, that is a one line diagram of a simple power system is shown in diagram. So this is the diagram, this is the network that we are going to apply, and this is the data related to all the elements which are connected in this network. So we are having a generator 1, generator 2. So this is the data for generator 1 and generator 2. X1, X2 and X0 indicating that positive sequence, negative sequence and 0 is sequence reactances of this respective elements. Then T1 and T2. So we are having two transformers, T1 and T2. So the data which is given for the T1 and T2. L12 means the line which is connected between 1 and 2, that's why it is L12. And the line which is connected between 1 and 3, so that is L13, and L23 means it is line 2 to 3. So all the necessary data which is given over here, we are going to fit this data into the power simulator network. So that will be more clear to you once we feed the data one by one. So let us start the power simulator software. So this is the power simulator software, so in which this is the the tools that we are going to use. So first of all, you need to put this into the edit mode. So you have to select the edit mode, and then after file and new case. So yes, we are using the new case over here, so that's why it is new case. And you need to put a grid, so that will be more easy to you to draw any system over here. So draw a grid lines. So grid lines will be helpful to you to draw any of the elements, or to put any of the elements with a proper symmetry. So now let us use this diagram that we have used over here. Just a moment, I am showing you the diagram. Yes. Yes, this is the diagram that we are going to use. So here we are having bus number 1, bus number 2 and bus number 3. So that we are going to draw over here. So go into the draw, and in draw select the bus. So tap where you need to put the bus. So this is the nominal voltage which is showing over here. So we are having a 220 voltage nominal because our transformer is having 220. So we have placed over here one bus. Now second bus according to the diagram. So we are placing the second bus is over here. So second bus is showing the nominal voltage 220 because as we have selected the 220. So just put the OK. Now the third bus, that is we are putting over here. So that will be easy to draw the diagram. So the nominal voltage is 220 according to our data. So we are having all these 3 buses. You can expand the length of the bus by selecting the bus, and as per your requirement you can extend or you can compress the length of the bus. So you can see over here, this is the, so you can see over here, this is our bus number 1, bus number 2 and bus number 3. So bus number 1 is connected with the transformer T1. So transformer T1 is having 20 volt primary and 220 is the secondary voltage. So the bus nominal voltage will be 220. So that's why we have selected the 220 volt for each bus. So this is T1 and this is T2. So both are transferring voltage over here. So the nominal voltage of this bus will be 220 kV. Now we are connecting it with the transmission line. So transmission line L1, L2 and L3. L1, L2 and L3 is having this reactances, means positive sequence, negative sequence and zero sequence that we are going to feed in this program. So you can take the snap of this while you are drawing that. This I am just maximizing and minimizing the screen over here. So let us see the Powerball simulator. Okay, now on this select the next element, that is transmission line. So this is the transmission line that we are going to use. So give the single tap where you from where you need to start, and if you need to change the path, then give the single tap over there also, and again single tap, and where you need to end at that point you need to give double tapping. So this is the double tapping which is showing that we are giving the we are feeding the data over here. So series reactance that we are putting over here, that is, so over here the per unit reactance that we have over here, you can see that this is the diagram. So in this you can see that between line 1 and 2 we are having the per unit reactance, that is 0.30, 0.125 and 0.125 over here. So just we are giving reactances, we are feeding the reactances over here. So let us start putting the reactances over here. So 0.125 and for going to the fault info, and this is the zero sequence impedance that is also given over here. You can see that zero sequence impedance. So we do not have resistance over here, so we are taking the reactance. So this is 0.30. So we are putting 0.30 over here. Okay, so just give OK. So this will appear. You can compress or stretch as per your requirement. Again, going to the transmission line. So we are starting from this point and we are changing the path at this point, and by single tapping and double tapping is over here. So between 1 and 3 we are having reactance that is over here, you can see that between 1 and 3, so it is 0.15, and the zero sequence is 0.35, so 0.15, and going to the fault info, over here it is 0.35. Or stretch as per your requirement. Again, going to the transmission line, start from here, so give the single tap over here. If you want to change the shape, single tap over here, again single tap over here also, and double tap over here. So between 2 and 3 we are having this data. So 2, 3, so this 0.25 and 0.7125, so 0.25 and into the full info 0.7125. Let me check again, it is 7125, yes it is correct, 7125, okay. So these are the formation of the transmission line over here. Now here we are going to connect the transformer and generator. So for connecting generator 1 and generator 2, we again require a bus bar. So again we are putting 2 bus bar over here before generator, and then after we will connect the transformer T1, T2, generator 1 and generator 2. So let us start with the bus bar again. So yes, this is the bus that we are putting over here, and the nominal voltage it is showing over here because our generator is having 20 kV, so put it over here, it is 20 kV the nominal voltage, so change it 20 kV, and the orientation which is shown over here, and for the display, you can change the bus information, display, or attached devices, geography, and custom as per your requirement. So yes, the display is say upside, means whatever it show that will be upside, so give over here, and that is okay. So you can change the orientation also. Over here you can see that the display is right. Okay, so this is the display of the bus. You can stretch or compress as per your requirement, and again you need to put a bus over here. So I am putting bus over here, so having same 20 kV, so no need to change, and just put OK over here. The orientation you can change over here, display that is right, so it will be shown the right. You can move as per your requirement, and you can stretch or compress it as per your requirement. So this is the buses on which we need to connect the transformer and the generator. So let us select the transformer, then over here the transformer. So we need to connect between 4 and 1, so just tap on the 4 and then the 1, so the transformer will be appear. So this is the data that we need to feed over here. So let us start with the nominal kV is 20, and to the bus is 220, so no need to change this. And for the transformer, the reactance that we need to put over here. So the reactance is for the transformer 1 is 0.10, so give 0.10 over here, so 0.10, and going to the fault info, and this is the reactance, zero sequence reactance, so that is 10. And the configuration that we are using over here, in this you can see that the star grounded, so select according to the star grounded, so Y grounded, you can scroll it, grounded Y, So both are grounded, so select grounded Y, and give OK over here. So this is your transformer number 1. Now connect transformer number 2. So between 5 and 2, so put single tap on the 5 and double tap on the 3. So again the transformer data will be appear. So we are giving it a name of the transformer, means nomination to the transformer, delta and star grounded. So delta is not grounded, star is grounded, and the transformer T2 is having 0.10. so feed the data accordingly. So put 0.10 over here and go into the fault info, and over here it is again 0.10, and over here you can see that delta is not grounded, star is grounded. So grounded Y, delta grounded Y. So delta is not grounded and star is grounded, so select this and give OK. So this is the data that we have fed for the transformer bus bar transmission line. Now put the generator over here. We can put it like this. So we can take the image of this diagram also for our reference, means for your manual. So like this, and now put the generator. So this is the generator that we are going to use over here. So I am connecting generator over here. Now this is most important to put the data for the generator. So let us see how we can put the data for the generator as per the given data that is over here. Also we are going to connect generator 1 over here. So the thing that we forgot over here, so double click on this bus will become slack bus, so select slack bus over here. So that will become slack bus, and now let us connect the generator over here. So first of all we are connecting the generator over here. Now feeding the data for the generator. So let us feed the data for the generator first. So here we are testing this generator for the setup. So put the megawatt, the set point is 0, and then after going to the fault parameters. So fault parameter, in this the positive, negative and zero sequence reactances are given over here for the generator 1. So generator 1, you can see that the positive, negative and zero sequence reactances are 0.15, 0.15 and 0.05. So put this 0.15, 0.15 and 0.05. Then after the neutral ground impedance we need to put over here. So again we are going into the example which is given over here. You can see that the neutral to each generator is grounded through a current limiting reactor. So when you divide 0.25 with 3, so your answer will be 0.8333. So we are putting 0.8333 over here. So 0.8333 over here. Now go into the display information. In display information, select up. So you can see the parameters that you are changing over here. So it is selected up over here and give OK. So your generator is appear over here. You can see that this is your generator, and the megawatt and MVA rating which are also shown over here. You can take the small over here. You can move the numbers of the bus also, so you can see it clearly. So this is the number 3. Okay, now connect the generator number 2 over here. So we are putting generator number 2 over here. So we are feeding the data for the generator number 2. So generator number 2 is having the reactances, that is 0.15, 0.15, 0.05. So it is again 0 over here, and the fold parameters in which 0.15, 0.15 and 0.05. Now going to the neutral, that is neutral to ground impedance, that is 0.8333. Now in display information it is shown up over here, so it is okay. Now in this, so before you run this setup, just again check the parameters that you have fed by double clicking the element that you have connected. So this is the information which is showing that which is connected on the bus number 1. Then the parameters that we have fed, that you need to check the firstly before you running this setup, and you can see that the neutral to ground impedance, whether it is inserted or not. So all the parameters that you need to check before you run this setup. Now our design is ready. Now we are running this program. So now we are running this setup over here. So I'm maximizing the screen, and you can take this screenshot of this, so that will be useful to put this diagram in your manual. So now we are going to towards the run mode enable. So as the run mode enable, the grid will be disappear. So this is, so our program is run on already. So just going to the parameters that we need to check over here. Now go into the tools. So over here you can see that this is the tools that we are checking over it. Now in the tools, go into the fold analysis. So fold analysis. So this display will show that this is the program that we are running over it. Now single fold, go into the single fold. Now in this, all the information is shown by the your system. So in which you can see that fold type, single line to ground, line to line fold, 3 plus balance fold, double line to ground fold. You can perform any of this, and you can plot the, say, take the Y bus matrix for the load flow studies also. So yes, here we are need to check the in our data we need to check the fold is at bus number 3. So all the folds that we are creating are on the bus number 3. In each and every parts you can see that this is the see at the bus number 3, at the bus number 3. So we are selecting bus number 3 over here in this diagram. So this is the bus number 3 on which we are checking the fold. So also we are having the fold impedance that is given in this. So the fold impedance which is given over here, you can see that this is the point where we are applying the fold. Then fold impedance is 0.1. So change this 0.1 over here. These are the data that we have already fitted, and then after press calculate. So we are pressing calculate over here. So this is the calculation of single line to ground fold. So you can take the snap of this. So this will be useful for the analysis. And in the single line to ground fault, you can also draw the bus matrix. So this is the Y bus matrix. So these are the different parameters that you can check. Or you can analyze. So bus record, lines, generator, load switch, shunt, and Y bus matrix for single line to ground fault. So at the single line to ground fault at bus number 3, which is having fault impedance is 0.1. So you can see that the fault current, which is all the quantities are in PU. You can check is the unit is ampere and in amperes also. So this is the data which is in the ampere, and this is the data in PU. So this by this software you can solve any network which is having single line to ground, line to line fault, 3-phase balance fault, and double line to ground fault. You can calculate any parameters from this software. So we can again take the snap of this. You can take the snap of this and the amperes unit also. So at the bus number 3, so let us take. Also you can check all the parameters like Y bus for the load flow studies. So this is the Y bus of the single line to ground fault, and let us check this for the line to line. So for line to line we are calculating at the bus number 3. So this is for the line to line fault at the bus number 3, and this is in the PU. So these are the readings for the line to line fault. So let us take the snap of this also. So this will be useful to put this in your manual. So line to line fault, and for line to line fault, now let us take this having same data with the ampere unit. So this is in the ampere. So whenever the fault occur at the bus number 3, so this is the these are the data that will be that you can take for the contingency analysis of this of this given network. So let us take the snap of this also. Also you can check the parameters, say positive sequence, negative sequence, and zero sequence bus matrix. Similarly for bus records, you can see that the say phase voltage A, phase voltage B, phase voltage C, then phase angle B, phase angle C. So you can take the phase angles also. You can take the analysis. You can perform the analysis of the lines also. You can check the performance of the generators also. You can take the performance of the loads also. We don't have the load in the system, so that's why load is not showing over here. Now the shunt buses are not present, and you can take the Y bus matrix also. Now for the 3-phase balance fault, so again calculate for the 3-phase balance fault. So yes, for 3-phase balance fault you can see the ampere means it is in the ampere unit. So you can check the zero sequence, positive sequence, and negative sequence Y bus matrix also. So yes, we can take it for the further calculation if it is necessary. So let us take this snap of it. Also the PU units of this 3-phase balance fault. So in this you can see that the magnitude, then the fault current magnitude, then fault scale magnitude, then the fault current angle, and the subtransient phase currents, and the degree of the respective say phases. So this is the data which is showing for the 3-phase balance fault for the bus. So let us take the snap of this also. Now let us check for the last fault, that is double line to ground, for the same data. So let us calculate. So this is for the double line to ground fault, and the parameters you can see each and every parameters that you can see over here. So this is how this the software is very useful for the calculation of the say the symmetrical faults of the system, having single line to ground, line to line, then 3-phase balance and double line to ground. Now let us take the snap of this. Now let us check the data again in the ampere units. So this is these are the amperes of the magnitude of the fault current when the fault will take place on the bus number 3. So you can see all the data related to this fault. So let us take the snap of this also, so you can attach it in your manual for the analysis. So this is how we can solve any network, and you can create the fault wherever you require, and you can check any of the type of the fault which are given over here, and you can analyze the data of the system from the system for the given network. So this is what I am done for this experiment number 6, 7, 8 and 9. And if you have any query or any doubt related to this 4 experiments, then you can call me and we can solve your doubts in our doubt solving session. And if any further query arise related to this, then feel free to call me anytime to solve your doubts related to this topic, as well as any topic related to the electrical engineering. Thank you very much, student. Thank you all. Jai Swaminarayan.